I have a question for you. On older versions, when the inline steering first started, if you did a hot start of the model, the CMS wave started at the back at the top of the wave spectra file, rather than wherever you were in your sequence when it stopped. So I guess my question is, has this version been tested with a hot start to verify that the waves and flow are in proper sequence, sort of where it starts up halfway through your run?
That's a good question. Yeah, go ahead.
We updated it about a year and a half, 2 years ago, and found the error in the CMS code and fixed that. And so now when you hot start, it sees what time the flow is set to start at, and then it skips over that number of wave runs so that the times match up. So it should be working now in later versions of CMS. I would say pretty much any version of CMS 5.3 or later should have that.
And is that done by the date stamp in the index in the wave file, or by the number of wave conditions?
I believe it actually looks at the date stamp in the file.
Okay, thanks.
I'll go back and check and make sure, but yeah, I think it does look at those dates in that energy file.
Yeah, thank you for that question. If as any you and others online, as you continue to work through some of these and encounter issues, please let us know, because we are in constant contact with Aquaveo. We are their partners and they are our partners in this. So as you encounter issues, please let us know, and then we can work on those as quickly as possible. Okay, so here is our lovely CMS flow simulation. You can see that in there. And now we're going to make a CMS wave grid. So we'll start with the new coverage, models, CMS wave, not model. It's the map feature. Excuse me, I got to move some of these dialog boxes from the chat around, etc. Okay, map data, CMS wave, should be the grid. Observation cells, nesting point structures. I think I'm in the wrong spot.
Liz, I believe it's just C grid generator.
Ah, thank you. Okay.
And then I didn't realize that they had made that change in the newer version, but it's just a CGID generator. And then you attach that to your wave simulation. I believe that's
yeah, it represents a Cartesian grid. So it used to be there's a CG wave model, but that's a different model.
Yeah. Yes. Thank you, Lila. Yes, that's Cartesian grid, which it is Cartesian. And I will make a note to update that in our slides before we repost them. That's the difference between 13, 2, and 3 of SMS. So grid. Okay, so we'll zoom in our area of interest and we'll create a CMS wave grid starting offshore. Voila. And just to see how that compares with our quad tree grid from Flow. Okay, it's much larger. Maybe we don't need waves as far offshore. So let's go back to our C grid generator and edit that so that they're pretty close. We can make that the extent of our visual. We'll make those angles a little closer. Okay. Oops, that's why I'm not clicking the right rotation tool. Here it is. And although we don't expect waves up here, so it's not as big of a deal that these don't overlap in the shoreward side of the simulation. We don't want to waste computational time either, so we'll make that a little smaller. Okay, next we want to add some refinement points. So we'll add some feature points. We can add one here. Just to see what it looks like, we can add one up here if that's an area that we care about. But because our first one is here, everywhere in this line is going to be high resolution. So even if there was a point right inland or inland of that point that was of interest, it would be duplicative to have another refinement point, but maybe there's some structure or some offshore spoil borrow area. We might want to add, for example, another little pocket out here for refinement. Okay. So if we want the same level of refinement on all of those, we can make the refinement the same for each. So we'll set, this is going to be your base cell size is going to be the smallest cell size at your refinement point. So 1 meter might be too small, but we can use 10. And then from there, we simply move into convert, map to 2D grid. And we'll call this CMS Wave Grid 1, 3 refinement points, in case we want to do another. The angle is 167. We know from the flow module, so we'll just do that. And then use the refinement point option. Let's just for fun leave refinement in X or I, but we'll turn it off in J just to see what that looks like. And don't forget to add your scatter set that corresponds to your elevations. If you want to extrapolate, then you probably want to include inverse distance weighting. Hit OK. Mark cells above datum as land. You can turn that on or off. You can change what that threshold is.
Okay.
So let's just turn it off.
Yeah, increase your maximum, I think the cell size.
Oh, thank you. Thank you. I forgot that. That's going to be really busy.
Yeah, I made a mistake before. I said, why? They all look the same.
Yep. Okay, so we'll do that again.
Well, even with square cells, you could tell how fast that built. So it was really quick.
Yeah. So convert to 2D grid. So you want to change your maximum cell size to whatever you want. Let's say 250. And just see what this looks like. Okay, something about that still doesn't look quite right. But it will be helpful to see the cells.
Mm-hmm.
Okay. So we have 3 points, and they are growing in all of the X directions, and it looked like they also grew in Y, and that may be because we set them to grow in both directions on the points themselves. And this isn't a great grid, but we have the one from the files.
You can't turn off the inner growth per cell. It's for all of them or not in either the I or the J direction.
Okay, got it. All right. So this is our CMS wave grid, and we can turn on our other grid just to see the overlap between the two. Here we're expecting, I guess, waves will enter the inlet and are important for transport here. But once this begins to split and gets a certain amount inland, we don't expect ocean waves to be that important, or maybe we don't care about them for the purpose of this exercise. So we'll move on. Now we can move into the spectral forcing. So that'll be new coverage, spectral, that's a generic type. And we have a singular buoy where we have information. So we'll click that and define its attributes. We'll create a grid. By default, it's going to coordinate to the grid angle. Hit OK. Here's where we define the frequency and angle distribution. And we can specify how those are discretized, although usually a uniform discretization in frequency and direction are adequate. Okay, before we forget, let's update our reference time. And our reference time, we don't know off the top of our heads. What we can do is pull up our wave spectrum information. So here's the ENG file, and it's an ASCII file, ASCII text, so we can just look at it in a notepad. And we can see the first time corresponds to 2013, January 1st, time 000 hours. And so the next components are going to be your wind, speed, and direction. But that'll give us our reference time, and we'll use that. So come back here, reference time setting as 01, 2013, in time units of hours. Okay, so our spectrum, it's a John swap spectrum, and we're going to import the parameters. We have some information by looking at our grid earlier. This is about 20 meters of depth where we have our our buoy. So as you can see here, we're going to move into the wave spectrum folder. And we've already talked to Aquaveo about this. This is an issue. It will only find a .txt, which is a pain, but not impossible to work around because this is a text file. We're just going to copy it so that we have our original file. We don't mess that up. And we can just rename this as .txt. It warns you, but they will not change the file or corrupt it in an irrevocable way. So now that we've done that, we'll come back and we see our lovely little spectral file. Open that up. And where is it? I did this earlier. Oh, actually, it might be here, but it doesn't say. I'm just going to say generate. No. Okay.
Yeah, this
Okay.
is all kind of changed. I'm not sure why that's not working,
So
but we'll figure that out. I
that
think if you take that energy file and then just drop it into the interface.
Okay, that's right. This is the one that we talked about. Oh, instead, I will move the one with the .eng extension so it recognizes that. Multiple fire leaders for this have been detected. It is a CMS wave.eng. Great. Okay.
Yeah,
Spectral and an X. Okay. If I hit cancel and then just say, I'll click this, and down in the bottom corner, it'll have that information. So I'll just make a note to myself. One, 4, 9, 7, 5, 3.
yeah, we've got to get that working better. That's
So now when we pull this in, we'll say CMS wave. Okay, seem to figure it out. And the spectral location is going to be at about the same location of our first one. Okay, and the grid angle orientation is 167. Okay, so we'll turn that off. And here's the name of our file. So we know that's our spectrum, but let's look at it. Is it not associated with a point? Maybe. Okay, no, there it is. That's our guy. Okay, we can look at some integration plots in frequency space. So overall, if you integrate over all of the directions, this is our distribution in frequency space. And we can do the same directionally. So we can see most of the waves are coming at 300 degrees, which is actually only about 45 degrees or less, maybe 35 from our grid angle. And it has the correct reference time in there. So that's great. So, oops, wrong one. Gonna make this wider. So here's our CMS wave grid. And we can now move into the model control. We'll keep this in half plane. We will define some bottom friction. We'll make it just a constant value, although we can vary that value. For our boundary condition, we can make this wider. See side 1. Okay, that's the side that we expect waves to be approaching from. So we'll select, and it'll give us an option for whichever one. If we have a few that we were playing around with different forcing conditions, we'll select that one. And we should be able to set the reference time again, 13. And if we say populate, this is currently a little bug that we've talked to Aquaveo about. See, it generates all of our times that are in the spectral file, but it doesn't bring these wind and magnitude and direction files over. We can prescribe a low, just a non-zero wind velocity. We'll keep the direction 0, but just so that we have information. In the output control, we can see if we want to provide the radiation stresses, just so we can look at them in case we had questions about the accuracy of the output, or wanted to do another simulation later without running CMS wave, but we just wanted the mean impact, so that radiation stress file, we could do that. We can turn off wetting and drying if we don't think that's very important, or we're having some stability issues and we can run without it first. We have all these other different parameters. We can include run up, not include it. We have money bottom characteristics that we talked about yesterday in some of the PowerPoints Mitch gave, reflection, roller effects. If we care about morphology, we typically do want to include these roller effects. And we can hit OK. All right. So now that we have that, we'll do a model check, make sure we're not missing anything. Oh, I know we are missing something. Oh no, we did. Okay, never mind. We did everything. Okay. Since that looked pretty good, we'll just start and see if this runs on its own. So this is CMS Wave in standalone mode. Any questions about what we did?
I think even I have questions about what we did. It's changed a bit since 13.2, and we need to test this out a lot more.
Yes.
It looks like it's working fine.
Yeah, I think the capability is there. It just looks different, and we need some backwards compatibility and some of the functionality of the tools, but for the most part, should look okay. So we can either let that keep running or not. And just for completion, let's set up the coupled simulation, excuse me. We can go to model control. We'll have our start time be compatible with the waves, which is not a big deal because our forcing conditions are tidal constituents, so they don't necessarily, it's not that we don't have data for them. Okay. Sediment, salinity, waves. So we can add that, inline steering. Since we've already created a wave simulation, we can go to models and find the simulation folder, click the simulation file, the steering interval. We'll do this every half hour. And extrapolation distances, we'll let the computer take care of this for us. And I hit OK, but now we need to do a model check. No model checks violated. Fantastic. So now when we go to
I believe that energy file was every 3 hours, not half hour. And the value you put there for that steering interval has to correlate with the times written to that energy file.
Yes, I see what you're saying, but it should be in this, it's not computing waves every 3 hours. So as it computes waves, it should be interpolating between time steps to get information. Right?
Well, the model control, when you're specifying that value there, it's telling the wave model to run at that interval. If you tell it to run every half hour, but in that file it's stipulated that they're really hourly, it's going to be grabbing a new wave right off the top every half hour. And so when you go to compare with your results, you may not get a good correlation. So your steering interval here needs to mimic what is actually in the wave energy file.
Well, I could see your results being different if you're running at different simulation intervals, but you should be able to compute waves every frequency that you specify within the change in wave period.
Yeah, but that's not what the steering interval is.
Right, right.
So what you can do is you set the steering interval to 3 hours, but in your output, you can turn on wave output from your grid and then output it more frequently. And you'll see how those waves are progressing through time and the energy that's evolving in there. You can't get wave information more often than you actually calculate the waves.
Okay. I think I'm hearing you correctly. Let me, okay, look at the wave only model control. So, but this is, so
It's every 3 hours.
the waves are changing everything every 3 hours, but if you have a different water level between hour 0 and hour 3, at hour 1.5, you can get wave values. It can compute waves, correct?
No, you only have the information for your wave model that's in that energy file. And so if you need more frequent waves, if you think you need waves at 1.5 hours, you need to provide wave spectra at 1.5 hour intervals. You can't create something from nothing there. They've got to match up.
Okay, maybe we need to talk offline because I'm not sure I'm totally following, but
Yes. But for right now, yeah,
yes, I'm just going to put
your
3.
waves are specified in 3 hours, so that steering out interval needs to be 3 hourly.
Okay, so
Yeah, when we do the steering, the water level will be passed, from the flow to a wave model. So we don't need to specify water level in the wave model. They leave, as 0, the data. But the wind, definitely flow, you need to specify the wind, but wave, you need to specify the wind, separated, even they are identical, because the wind information will not passing from flow to wave or wave to flow.
okay. So day 2 of waves is less than yesterday. Just have about we're an hour and 10 minutes in. Is there anything else that we haven't discussed that folks have questions about?
One thing I'd like to show at some point after the questions is how to use the WISP portal and get the new information from the WISP portal. And that we have a tool there that provides capability like our old WaveNet did to be able to get WISP station information in a CMS wave format. And I'll show that in a little demo, but we can answer some questions now.
Yes, thank you for that reminder. I'm going to keep everything up on SMS so that we can come back to it. But since we don't immediately have questions, Mitch, do you want to share
Okay.
a demo from grabbing information from WIS?
Mhm.
Yeah, I'll share my screen.
Okay.
I'll stop.
Yeah, one I think important, application is to have the sediment transport. I guess you will cover that one, right? So the coupling, the full coastal process, is really advantage we can apply for the sediment transport. We have not touched sediment transport, but I guess you were, right? You were describe, right, capability.
We do have slides from sediment transport, although is Honghai covering that tomorrow?
We'll be covering some post-processing. We just don't have time to cover all the topics we typically cover in our full 5-day workshop. We had to cut some things, and that was one of the things that we just didn't have time to put in for these 2-hour sessions per day.
Yeah, Mitch mentioned yesterday how to set up a sediment transport. Yeah, the basic thing. Yeah.
We've done a lot of great work for different districts with the sediment tracking, Honghai. So we can also point folks to the CMS website where Mitch has some of those recent publications talking about the different applications and uses. And the sediment mapping is something that we're coming up with some documentations and some little quick guides for. So in addition to this webinar series, next FY will be coming up with more little how-tos.
Yeah.
All right. So what I'm showing now is the updated WIS portal. I'll go ahead and go back to the full screen here. It's basically wisportal.erdic.drin.mil. And we've got points all over the United States, Alaska, Hawaii, Guam, some other of our territories. And basically they have been working for, since 1979. I think we have files we've pulled together over 42 years of hindcast data for pretty much all of this area. And so we have consistent wave information for those time periods. And so what you would normally do is you're looking for some kind of waves that you can force a CMS wave or some other wave model. And so this is really applicable for anything, but this one tool I'm going to show is only for CMS wave for right now. But we're working on getting capabilities in there, expanding it so that we can work with ST Wave or some other models if there is a need from our users. But basically, this is the area we're talking about with Shark River, New Jersey. And so you can see there are a couple of different WIS stations that are relatively close. If I turn on the NDBC buoys, you might see a few of those. They're much farther out. These MEDs, they're only Canadian buoys. So really the closest spot that we have, since we don't have CDIP buoys implemented yet, is the WIS stations. And so if you wanted to, you could select one of these WIS stations. It pulls up some basic information about where that station is located, when we have time data for. So right now, this Atlantic station is from 1980, January 1st to basically the end of 2023. We just updated this yesterday with the new hindcast for 2023. And so it also gives you what that depth of the station is in relative to the water here. So what we can do is get a lot of different information about the data that's been collected. But last year we added in a new tool that's at the bottom here where we can gather input for the models. And so we can click that option. We can choose which year or which month in what year to get the data. We do limit it to just 1 year at a time because the spectra for that long time period is quite large. So if you want to use this tool, we can just choose, I'll choose 2013 since that's what that wave model was for. I'll gather just January, so it'll come back relatively quickly, hopefully. And then the user information, they would have to provide 2 bits of information. One of those being the grid orientation as it was written out by SMS. And so that's 167 is what we've been using. And I think we've been using around 20-meter depth for that offshore edge of the grid. And so we can use this and download a file from this WIS server, this portal server. So I'm not sure how long this is going to take. I think it should be relatively quick. And there it is. So it comes in and I'll just save it to my downloads folder. I'll open it up real quick so you can see what all kinds of data that we have inside of it. And it's still doing something here. All right. So in the what files we provide, there's several different ones here. And they have different bits of information, what is in each one of these and how to read the different formats. But what we're interested in for the most part is this .eng file that is a half plane representation of the energy as it's moving towards that shoreline. We gave it that angle. And so through here, you can see the different energy for the different orientations. We've got it from, looks like it's second hour here, first hour. It does have some wind direction and speeds as well included in this bit of information. So if you wanted a full plane representation, there's this .ascii or .asc file that is actually the full representation at 72 different direction bends. And so we have that same information. So just for your own information, that's what we've got there. These others just contain a little bit of other details about the information that was extracted. So if we look at this .txt file, this is an SMS generated or formatted file. So it has information about the wave angle, height, period. The gamma and NN values are also part of this file. So you don't have to calculate those or get those with that spectral defaults tool. If we had information about a second peak or something like that, it would be in the second set of values right here. But then we also have a wind, a fetch, which looks like it's not exactly what we want right there. And we've also got the depth. So anyway, it's got that information that we need. And so we've got that file. And what you would normally do is, as Liz pointed out, how to bring in that other .eng file. You would do the same thing. You would load this, assign it to a certain point in the grid, provide that angle, and then you would be able to associate it with the CMS wave run for that particular time period. So I'm not going to go into, explanation more than that. We're going to probably re-record this part of the demo because this is being used for to keep on file so that other people can watch a quick video and see how to run things. So we may re-record today's wave demo part so that it's a little bit more concise and without all the commentary that we had in there. Our own confusion about how the interface works since they're relatively new and it's changing. So are there any questions about, this particular tool or anything else as far as the WIS data portal or anything in particular? I see Bruce. Yes, what would you like?
Yeah, it's hard to read the screen that when you're doing this, but when you first pulled this data, you did it for CMS Wave. Is that correct?
Yeah, so right
Yeah,
now
I
the
can see
only
that now. So, okay, so when you showed us the different data types that were downloaded, you said there's the full plane spectral data. How would that get used in CMS Wave?
so in the options that you have for setting up CMS, when you first generate, as she showed, you first generate, it actually generates a full plane grid with information. And then there are tools within. Let me just go ahead and pull up my SMS. And I think I've got it far enough along to where I might be able to show what I'm talking about here. Let me go into the spectral information here. So this particular spectral energy, this is a full plane representation of the energy. So this could have come from hand input, or it could have come in from a buoy or this with station, something like this. This will have information from many different directions and angles. As you move and go into your wave model control, you actually tell CMS Wave that, hey, I'm going to only be using a half plane. And so that what that would do is it would generate a 180-degree grid, spectral grid, where directions are only coming from those directions. If you wanted to continue using the full plane grid, you could do that. And it would create the full plane grid for your option to be able to be specified.
But you can't actually use the full plane input wave data on your just your side one of this grid.
That's correct. I'm trying to remember what we did to get around that. I think the second option here, full plane with input reverse spectra, I think somehow we've got to specify on side one, and then we also specify on side two. Liwak, do you remember if you specify just a full plane and you have it pointing to that data, but you're only specifying it on this side, does it actually get the information from, does it go for the full 360 degrees?
You have to assign a spectrum for the other opposite side.
So you would end up having two different spectra, one for the side one and one for side two.
That's correct. That's correct. Yeah, because
it seems to me that if you have a full plane that has information for all of it, somehow it might be double specifying when you're running it the other way from the second side.
Each side cover 180 degrees. So the opposite side cover the other 180. So together,
yeah, I think we need to figure this interface out a little bit better and be able to talk about this a little bit more.
Yeah, I think you are right. Yeah, we talked to Aquaview before. Maybe we need to add some kinds of really, I think, a description here.
Because it seems to me we've got a full plane. We shouldn't have to specify two different sides. That we should be able to somehow do this. I don't know. Let's talk about it a little bit more.
Yeah.
But I think this question is still up in the air.
Yeah, the wave generator we have is not straightforward. You can only generate, one single mean direction. But when you have a full plane, the other side maybe the island effect, they may have a totally different wave characteristics.
Right. So I guess what we might end up having to do is take this interface and have one half plane or one grid that's fed at 167 and then another one that's the inverse of that, or the
that's correct
360 minus 167, so that we get the angles oriented the right direction.
Right.
And then we would have two different spectra to be able to assign to each
That's
side.
correct, because in the width is a full plane. Any the field, ocean, coastal, a buoy is a full plane. So easily we can split it. Yeah.
Okay. Yeah, so we just need to figure this out a little bit better. We might have some other tools that would split that spectra
Okay,
and not have the user have to double do this particular thing.
Yeah.
okay, and
It's-
while you've got this page up, how is that depth value used?
So this depth value, so what happens with this tool, we're getting data from these locations. And so we know this particular point, it is at 28 meters depth. Different gauges are at different depths. And we know what our near shore area is. So we actually perform a 1D transformation
Okay, yeah.
of the information from this deeper water buoy or station to the local edge of our grid. And in that process, it also changes some of the period and directions of that information. And so you have to provide both. You need to know what your near shore depth is for that transformation process. Does that answer your question?
Yes, it does. Thanks.
Yeah,
Okay.
that's correct, Amici. I think for coastal application, usually the full plane is not really full plane. We have a wave coming from the ocean, but the other side just wind generated the wave. So we don't really need a spectrum because it's land, But for example, like Hawaii Island, you do have, from the opposite side of the ocean, so the wave coming from different region of the
Yeah,
ocean.
I think we had a user one time that was doing an area where it was like at a promontory. So you needed the waves coming from both directions. And so we had to have some way to provide more than just 180 degrees for that. And so we're trying to figure out the best way to approach that.
It's not too often, but sometimes we do run into a situation.
Yeah. So Randy, did you have a question?
Yeah, Mitch, just quickly on the WIS, kind of more specific to that. I'm glad to see that this data portal is up and working. And I believe you said you just recently, or it was just recently updated for the 23. Is that a plan to do that annually?
Yes, we do that every year, and
Okay.
it usually takes until this is the earliest we've ever been able to provide a hindcast for the previous year. Normally they come around in October, but we've got all of our processes done a lot more efficiently now. So we're trying to get the information out by June or July, if possible. Right now we're delayed because at least for the Great Lakes in Alaska, we have to wait on ice fields to be populated. And we're also using ocean weather modified winds for all of our hindcast runs that we do. So we have to wait on that processing. So we have to, get those files from them. They have to wait until the end of the 2023 period. They process them. That could take 3 to 4 months. And so we do this on an annual basis, and getting these hindcasts done usually June, July, August, sometime like that. And then we run some validation and verification tests just to make sure that the information that we get is adequate. We have co-located buoys with NDVC and different buoys, so that we do some tests to make sure that the WIS answers match well enough with those observed information from the buoy data. So that takes another month or two. So yeah.
Yeah. Okay. And the second question, do you know if there's been any discussion or thought or plan of going back pre-1980 and maybe even more specifically going back to some what are known to be significant historical events to kind of fill in the gap there for waves? Or have you had any discussions? I know I talked to Bob Jensen about this a couple years ago, and he said that it would be possible to kind of hindcast specific events, but I don't know if that's on the radar or if you're aware of that.
I doubt that any of that will happen in the next year or two, mainly because they're changing the way these hindcasts are done. Right now, we have 5 different domains, and each one of these domains has 3 or 4 different levels of points. So you see one level right here and one nearer shore. Each one of those is totally separate. And so we are in the process of moving all of this from the existing WaveWatch 3 in the old format and the WAM grids that we have to a newer WaveWatch 3 process where we're going to have a global grid, one grid that does everything. And I doubt they're going to get to updating the hindcasts for other than, just the normal hindcasts within the next couple of years. After that, once we've rerun all the 40 plus year hindcasts on that new system, there might be possibility for them to go in, but I think that would be like 4 or 5 years out.
Got it. Okay, thank you. Appreciate it.
Yeah. Mohammed, or I'm not sure which one came in first, Mark or Mohammed.
Yeah, this is so Sophia and Mark. You just mentioned WaveWatch 3. Did you mean WIS as far as the hindcast model?
So WIS is a model that uses some kind of inputs. And so there's processes that we have. So it's basically a model based on a model, if that makes any sense. And so what we use is WaveWatch 3 grids and WAM grids in certain areas right now to do all of the wave calculations. And then there are WIS processes that we put on top of that after the fact. And so we're changing that underlying grids from the old WaveWatch 3 and WAM grids to one big, more resolved WaveWatch 3 grid that also is able to calculate the ice flow.
Okay, we've used WaveWatch 3 before, but I was told they discontinued their at least update providing hindcast. I think they stopped at 2019, I want to say.
Okay, yeah.
The other question was, so to use that WIS data, we just need to download the period of time we're looking for and then drag the ENG file under the map data. And is there a wind, the wind information, is that used in the model? Can it be used from that import?
So that's the one thing that Liz showed is right now when you pull in the spectra from a buoy or the WIS stations, it does have that wind information as part of that data. However, there's a when you go to populate the grid, let me just show it again.
Yeah, it's not. We're trying to do that, and it's not. Doesn't look like
right. So when you populate it, even though it's in the spectra, they must not save it internally in SMS. And so when it goes to be populating down here, they don't still have it to pull this in. So we have to provide a second step right now to basically take that information or some other wind information and then cut and paste it into these 2 columns so that we can provide it for our run. So that's something that we just reported this week, and I'm hoping we can get a fast turnaround and get that fixed in, the next month or 2.
And when we select a near shore depth, so you said the example you had, the depth was at 28 meter, and then maybe we pick a gauge that's a little closer to 10 meter. Is the wind also, is anything done to the wind to bring it near shore?
No, nothing is done to the wind at all. So basically the wind that you get is the wind that happened
Offshore.
At that gauge. There's no way we can do a good transformation for the wind. So we're just assuming that the wind that came from that gaze that may be way out here is the same at this point.
Okay. Thank you.
Excuse me. Sure. All right, Mohammed. Are you there? Okay, I can't hear if you're trying to talk. Are there any other questions that we can go back over or explain a little bit better? Like I said, we probably will re-record the demo portion of this thing so that it's a little bit more concise and a better flow to it than what we actually have recorded here. And these files will be available next week. Any other questions?
We'll have a question. Can you hear me now?
Yeah, I can hear you now.
Okay, so when we transform the wave from offshore from 30-meter deep to the model boundary, is it just 1D like Snell's law linear wave, or does it have any account to bottom friction and other things that dissipate some of the wave height? Because with
No, I think it's truly Snell's law. Liwad could answer that better.
Usually transfer is pretty deep, so we don't count for bottom friction. Yes, it's very simple. Yeah, Snell's law. Yes. Yeah,
so
right.
has there, like, especially for big storms, and the old west data was typically when we transform it with from west to near shore, it overestimates the wave because of the wave height in the near shore typically kind of gets reduced a little bit in reality than the offshore propagation without the wave height losses. And then when you compare it to reality, the wave height is a lot less in the near shore than just transforming the wave from west or from a buoy offshore. And from our previous cases with WaveWatch 3, WaveWatch 3 had near shore or closer to shore stations that, with comparison with data collection, WaveWatch 3 was closer in on the wave height at near shore stations to measurements. So I'm just wondering, is the WES analysis now has any kind of verification with wave heights from field measurements? And is it comparable to WaveWatch 3, or is it still overestimates wave heights?
Yeah, to answer your question, it's a very good question. There's a lot of uncertainty, really, associated with the wave transformation. In reality, if possible, actually, you can run, CMS wave with a larger domain all the way to the buoy or the station. You can change the variable cell, or you can use green nesting. But really, based on my experience, sometimes we do have a gauge you can compare. Sometimes overestimate, sometimes underestimate. The with wave and the wave watch, the with product, that really depend on the model. Yeah, I think with wave is more like a theoretical, based on the equation. But the wave watch has a lot of empirical function, so it's totally different model. Behavior may be different. So really you need to really investigate, your study area, your site to confirm, which one, or you really need to do some kinds of adjustment as well. Yeah.
Is any part of ERDIC research still includes WaveWatch 3? Because I think I've seen some publication by Jane Smith related to WaveWatch 3 at a more recent date than data available to us from the WaveWatch 3 system.
Yeah, WaveWatch 3 is the NOAA product. I have a friend there in a research center. And that's, they add in quite a bit of empirical formulation. So the older, the wave watcher and the new wave watcher, they produce very different results. But the more recent one, because those empirical equations actually seems like agree, pretty reasonable. It's the coastal, the gauging. Yeah.
We have many different people here that are involved in the newer versions of WaveWatch 3 and getting it verified for closer near shore wave models, like having grids that are a lot shallower depths. Previous limitations were all deep water wave energy. So it's a big change when you get to where the wave model fills the bottom. There's a lot of work going into getting that near shore capability. And that's what I'm saying is we're eventually going to be using that newer version. So all of these stations that are relatively deep right now, we're going to have a lot more stations that are going to be closer to shore and hopefully will provide better near shore wave response than we're currently able to provide. Because like I said, we're just doing a simple 1D Snell's law transformation right now. But if we can actually get that near shore calculation, I think we're going to be a lot better off. Hopefully that answers your question. But.
Yeah, the WIS has an advantage because we go all the way back to Mitch would go back to 1950? Oh,
79 right now.
Yeah, it's very, very long, really, hindcasting information. The wave watch has much shorter, duration. So from design point, you have to make decision which one, you want to really apply.
I've done analysis to some barrier island settings when the near shore provides a lot more, accurate results for sediment transport and morphology compared to the WIS when I use the WIS offshore, because there is a lot of process in the wave propagation in those shelf systems. So we're kind of feeling like now we have to go back to use WIS, but what I'm gathering is that the current WIS data is a lot more advanced than the old WIS of the 1980s.
Oh, absolutely.
Correct.
Yeah. Although when we did start using the WaveWatch 3, which is now the older WaveWatch 3 for the Atlantic and Pacific grids, we did go back and recompute all of the WIS hindcasts from 1980 and forward with that newer grid. So it's not, don't think that if you're getting the 1980 data from WIS, we're using that much older technology. We actually reran this back in 2014 with the then current technology.
Awesome. That's good to know, because typically what I try to do is to try to run decadal wave conditions and see the changes over time between different data sets. So knowing that the older data is updated is something that I'll keep in mind. Appreciate that hint.
Right. So Liz just shared the link to the WIS webpage, wis.erdic.drin.mil. It's got a lot of information, a good project overview of what's gone on in the past and how it's evolved a little bit. And a lot of other data and publications are here. So if you have any questions, feel free to look this over and then contact this WIS info at USACE Army Mill. And that goes to about 5 or 6 different people in the group, and they can answer specific questions about WIS type stuff.